Let's say you were given the following substances. So you have H2O or water, hexane or C6H14, and magnesium sulfate or MgSO4. Suppose that your task is to prepare an equal number of particles of each substance. So what will you do? So obviously, you need to count the number of particles or determine the number of particles of each substance. That seems to be impossible at first because, of course, the particles are very, very small and we have a lot of particles here. So how do we determine the number of particles from this substance? Again, we can do that in the process of counting by weighing. So we can determine the number of particles given their mass. And let's say we have measured the mass of each substances, and let's say we have about 18.1 grams of H2O, 15.7 grams of hexane, and also 22.4 grams of magnesium sulfate. So again, we can determine the number of particles of each substance with the help of the concept of a mole, because a mole is the bridge between the mass and then the number of particles. Again, 1 mole is always equal to 6.02 times 10 to the power of 23 particles. It's like a dozen because a dozen, this one is also a unit, it's always equal to 12 pieces. So again, 1 mole of substance has the same number of particles with another substance. For example, 1 mole of A has the same number of particles with 1 mole of B. 0.5 moles of A has the same number of particles with 0.5 moles of B. 1.25 moles of A has the same number of particles with 1.25 moles of B. So again, the same number of moles means the same number of particles. And also, we have the greater the number of moles, it means more number of particles. And then the lower the number of moles means lower number of particles. So again, we have 18.1 grams of H2O and this amount of the other substances. Let's determine the number of particles from this one. Again, we can do that by first converting the mass to the number of moles and then from the number of moles to the number of particles. Let's start with 18.1 grams of H2O. The first step is to convert this one to the number of moles. And again, we need the molar mass for this. You can compute for the molar mass of this. That is the mass of dalawang hydrogen, then isang oxygen. That is equal to 18.02 grams of H2O. And then from the number of moles, we can determine the number of particles. Again, for every 1 mole of H2O is always equal to 6.02 times 10 to the power of 23 particles. I'll write P to make it short on this page, that is particles of H2O. Then it's equal to, we have 18.1 times 6.02 times 10 to the power of 23 divided by 18.02. So we have 6.05 times 10 to the power of 23 particles. Let's proceed to the second one. We have 15.7 grams of hexane C6H14. Then again, from this, from the grams to the number of moles. So 1 mole of C6H14 is equal to 86.06 grams. And then from the number of moles, we have the number of moles of C6H14 to the number of particles. We have 6.02 times 10 to the power of 23. 23 particles of H2O, 1 mole. And from this, we have 15.7 times 6.02 times 10 to the power of 23 divided by 86.06. So we have 1.10 if we round this one, because then the next digit is 8. We have 1.10 times 10 to the power of 23. Then the last one, we have 22.4. 22.4 grams of magnesium sulfate. So here we have the grams of MgSO4 to the moles of magnesium sulfate. 1 mole of MgSO4 is equal to 120.38, 120.38, 120.38, 120.38. Then from this one, we have 1 mole of magnesium sulfate is equal to 6.02 times 10 to the power of 23 particles. We have 22.4 times 1 times 6.02 times 10 to the power of 23 divided by 120.38. We have this number, we have 1.12. 1.12 times 10 to the power of 23. So again here, we're going to prepare equal number of particles. So on this case, we should determine which of the following contains the lowest number of particles, because again, that would limit the number of particles also, because again, we want to have equal number of particles for each of the following substances. So we have 6.05, 1.10, 1.12. So this one contains the lowest number of particles. So this should be the basis for the preparation of the particles. We have 1.10 times 10 to the power of 23 particles. And again, I should also prepare 1.10 times 10 to the power of 23 particles of this, and 1.10 times 10 to the power of 23 particles. So obviously, I cannot count this one. So in order to prepare this one, I need to determine the mass of this number of particles.